Hi there, and welcome back to another edition of 5th grade math. My name is Mr. Manella, and joining me, as always, is my assistant, Stu. How's life, Stu?
Ah, La vida es buena, Senor Manella.
Fantastic. Now, today we're going to be talking about comparing decimals. Do you know what I mean when I say comparing?
Are you referring to the great cupcake muffin incident of 2020?
What? No, that is not what I think of when I think of great incidents of 2020.
You know, the incident when I compared muffins to cupcakes as if there is a comparison.
All right, so I can't believe I'm asking this, but how do cupcakes and muffins compare with each other?
They don't!
Okay.
Muffins are just bald cupcakes. I don't trust them. What is even the point with making a muffin when instead you could have the sweet mouth glory that are cupcakes? Honestly, muffins scare me a little. I'm not built for too much bran. Goes right through me.
So what you're saying is muffins are a bald-faced lie, okay? Yeah.
Is that a dad joke? Because I don't get it.
Never mind. How did this comparison even come up?
On a late night Zoom call with my cousin Gene. You know, genius. He was trying to defend muffins,
Who?
but muffins are a scam. Either
Wait.
go cupcake or go home!
Wait, is Gene the guy you're always talking to on like the Zoom calls late at night?
Yeah, my cousin. Genius.
Oh, okay.
I think it's genius, but he corrects everybody.
Yeah, well, he's kind of a know-it-all, isn't he?
Yeah, takes one to know one.
Yeah, I remember Gene. He's a pretty smart Muppet. Okay, so is there anything else you want to compare muffins to before we get started with some actual math?
Yeah, those evil mushrooms from the Mario games. Those are some real muffin tops.
I may never get a muffin again.
Yeah.
Because of you.
Yeah, eat cupcakes.
I mean, cupcakes are better. I'm not gonna.
Yeah.
That's not really debatable to me.
Cupcakes. Always.
But I've never thought of a muffin as a bald cupcake. And we need to move on to the sweet glory that is 5th grade math.
Yay!
Yeah, in 5th grade we're learning a lot about place value. When we're looking at the value of numbers, we use that information to compare them. Which one is bigger, which one is smaller, okay? Or as we like to say in math, which is greater than or which is less than.
Oh.
Do those phrases make you think of that little sideways arrow you sometimes see?
Yeah.
Looks like this?
Like a little carrot.
Yeah.
Yeah.
It's so awesome that you can think of it that way because that's how we use it, okay? You're thinking mathematically.
Wow.
Nice, right?
Yeah. Yeah.
Let's get started.
Okay. Compare.
All right. Okay, let's review really quickly how to compare whole numbers. Do you remember when we compared a million to a billion? We said 1 million is less than 1 billion and wrote it in a number sentence like this. To make it more clear to understand, we stacked them on top of each other to show that 1 billion has digits at a greater place value, or as we said then, it had 3 more zeros on the end, which moved that 1 into the billions place instead of the millions place.
Yeah. But you know, the shortcut to comparing whole numbers is to see which one has more numbers. The one with more numbers is usually greater than the one that has fewer numbers, like 312 is greater than 5.
Sure is. Comparing whole numbers is a very straightforward process. We're going to find out today that it's a bit different with decimals. Okay, remember, decimals are small parts of a whole number. Okay, like pizzaghetti. Yeah. Okay, when we cut up a whole pizza into a lot of tiny little pieces and slices, we get pizzaghetti. Okay,
Yum.
we cut up one whole into little parts, one whole number, so we get decimals. Okay, more numbers in a decimal means smaller slices.
Yeah. Let's make pizzaghetti again after we finish learning about decimals.
Maybe. Okay, so when we compare two decimals, we're trying to determine which one is greater, or the larger number. Sounds simple, right?
Indubitably.
Just like we reviewed with the case of whole numbers, figuring out if something is bigger than something else is usually pretty straightforward. But with decimals, it can get tricky. For example, let's look at those two numbers you came up with, Stu, but let's make them decimals instead. We have 0.5 and 0.312. Which one do you think is bigger?
I'm going to go with my first guess. and say that 312 is very clearly larger than 5, Mr. Manella.
That's true, but are those numbers still 312 and 5?
They're not those numbers. Now they're decimal Getty.
Well, they're not food, but they are decimals now, yes. They have the same digits as the whole numbers you said before, but they aren't the same value now. The decimal point means they are parts of one whole number. We need to figure out how much those parts are worth. Then we can figure out which one is greater or more than the other. First, do you remember how to name these decimals?
Oh, yeah. We name them by looking at the place value of the last digit. So the 5 is in the tenths place on this one, so it's 5/10. And the last digit of the other one, the 2, is in the thousandths place. So that's 312 thousandths.
I'm so proud of you, buddy. You nailed it. What does it mean to be a tenth compared to a thousandth? Well, a tenth means if we took one whole and we split it into 10 equal pieces. Kind of like if you took $1 and changed it out for 10 dimes. Each dime is a tenth of $1. So 5/10 is like having 50 cents in your pocket.
You know what I'd rather have?
No, you don't need to tell me. We all know your deep and abiding love of the Benjamin. Did you know that a tenth of a Benjamin is $10?
Oh, huh.
So, tenth of $1 is a dime, okay? And a tenth of a Benjamin is $10.
Yeah.
See the pattern? Okay?
Yeah.
Those power of 10 patterns are so awesome, aren't they?
I mean, don't tell anyone else I said so, but they are pretty rad.
Aw, that's my little mathemagical muppet. You just snort?
Maybe.
Oh, well.
It's like how I purr.
I'm going to ask you to not make that a habit. It's not really... You know what? We're just going to move on.
Okay.
You've got a lot of nose, so it makes sense that you snort occasionally.
Yeah.
All right?
It's like a wind tunnel.
Okay, so let's level up and see if you can get to the next one, all right?
Okay.
What do you think a tenth of $1,000 is? Okay? Fun fact, they don't actually make $1,000 bills anymore, but they used to, okay? 100 is now the biggest bill that the Treasury makes. But there used to be $1,000 bills.
Whoa.
Can you imagine that?
Yeah, I want one of those.
It has a picture of Grover Cleveland on it.
Grover, like my cousin the Muppet?
No, like Grover Cleveland, like the 22nd president of the United States.
It's not fun to say I want a Cleveland.
No, it doesn't have the same ring to it as a Benjamin. I mean,
No.
a Cleveland?
No. Doesn't sound right.
No, definitely not. Yeah. Okay, what do you think 1/10 of $1,000 bill would be?
Wait. This is awesome. Based on my knowledge of the powers of 10,
Yeah.
I'm going to guess that a tenth of $1,000 is a Benjamin.
Bingo! Okay, as we would say mathematically, 1/10 of 1,000 is 100.
Yeah.
Okay, you're going to want to remember that when we're comparing decimals.
Oh.
Okay, if 1/10 of $1,000 is 100, then what would 5/10 of $1,000 be?
$500.
Right. Okay, so
Ah.
I'm going to throw something a little different at you. What would 312 thousandths of $1,000 be?
Well, is this a trick question? Because thousandths means we split something into 1,000 pieces. So in that case, 1,000th of $1,000 is just $1. You know, because you need $1,000 bills to get to 1,000.
Yeah, keep going.
So I think it would be just plain old $312.
And I think when we use money, you really get this stuff.
Yeah,
Okay?
I love money.
I mean, a lot of people do. And, because what can you buy with money?
I don't know. What could I buy with the Cleveland?
A lot of Takis, dude. A lot of Takis. But I think that if you went to the store with a $1,000 bill, you'd have trouble getting change.
Oh, yeah. Yeah.
Unless you just spent $1,000 on Takis, which would be too...
Then I'd have trouble carrying Takis.
Yeah, that wouldn't even fit in my car.
Yeah.
So, okay. So, let's take a look at an example. All right.
Uh-huh.
And we're going to see which one is larger. 5/10 or 312 thousandths.
Okay.
So first, we're going to look at a number line to help us compare. Then we're going to do it with a number sentence. Then I'm going to teach you a little shortcut.
Ooh, sweet.
Okay. Let's take a look at this number line. All right?
Okay.
It goes from 0 to 1. Okay, but we're going to pretend we cut it into 1,000 parts. Okay. And I put big marks at every 100 because I can't really put 1,000 marks on this
Okay.
whiteboard. That would be crazy. It would there just wouldn't be any room.
Yeah.
Okay, it'd be hard to see.
No.
Remember how you said 5/10 of 1,000 was $500? Let's put a little mark there to show how that works. So
Okay.
that's like right here.
Okay.
That's 5/10. Okay.
All right.
So where do you think a mark for 312 thousandths might go?
Well, 500 thousandths was the same as 5/10, I think, or we said $500 was 5/10,
Yeah.
and you put that mark at 5/10. So maybe a little bit past the 3 mark, because 312 is just a little bit more than 300. So maybe like right there past the 3, right? Right
Yeah.
there.
No, don't
Yeah.
erase it. Like
yeah.
here?
No, yeah, right
Okay.
there.
So I'll put the 3, 1, 2
Yeah,
there. Okay?
yeah. Okay,
All right. Now, I think that's the right place to put it. Okay?
okay. Yeah.
So now we have a mark to show where 5/10 would be and a mark to show where 312 thousandths would be.
Okay.
Which one's greater? Which one's, bigger?
Well, just like $500 would be worth more than $312. I guess that 5/10 is greater than 312 thousandths. And I think I'm right because it's closer to number 1 on the number line. So this was a really long way to answer that question you asked me ages ago.
Oh, we're not done. We're not done.
Oh, secretly, I love it.
I know you do, buddy. I know you do. Okay? And I want to make sure that you notice a few things before we move on because, like, you're super, super close right now. Okay?
Yeah.
You even, like, talked about it a little bit. I don't even think you realized it because you were so focused on the money that you actually sort of nailed what I'm going for already.
Whoa.
Okay? So, like, can you find out another way to name 5/10 that's really similar to 312 thousandths? I mean, you're so close.
Well, I mean, let me look at that number line again.
Uh-huh.
Okay, well, the 5/10 mark is also the same place as the 500 thousandths mark, right? Like, those were the same.
Mm-hmm.
So I guess another name for 5/10 is 500 thousandths. I mean, I guess what I'm saying is that 5/10 and 500 thousandths are the same amount. But if it were pizzagetti, it would be like 5 big pieces that were the same amount as 500 itty bitty little pieces. But both of those would be like half a pizza. Oh my gosh, I'm so hungry right now.
Yeah, me too. I think we really do need to make
Ugh.
pizzagetti again today. Okay, but also you notice something else, and that's that
Yeah.
5/10 and 500 thousandths
Yeah.
are the same. They're both equal to half of a whole.
Oh.
So yes, if we took a whole pizza and we cut it into 10 slices, and then we took 5 of them,
Yeah.
and then we took those 5 slices and cut them up into 100 each, it would
Whoa.
still be half of the pizza.
Yeah.
Okay, it's just that half the
Yeah.
pizza would now be pizzagetti.
Yeah.
But yes, okay?
Yeah.
All right, let's take a look at another little lesson.
Okay.
I think you're about ready for that shortcut. We've talked about how you can add zeros to the end of a decimal and you don't change the value. You just change how many pieces there are. And we proved that it works using our number line. So we have 5/10 and we added a few zeros onto the end so that we could solve this comparison. We didn't change the value, just the size of the pieces. See here how I changed it from 5/10 to 50 hundredths to 500 thousandths? They're all different names for the same amount.
Mr. Manoa, I think this whole comparison business would have been a lot easier from the beginning if you just used 500 thousandths to start with.
Yes, it would have. But I wanted to teach you why we can use 500 thousandths in place of 5/10.
Oh.
You know, that's why we make pizza from scratch. You can't appreciate pizzagetti unless you first put in the work of making the pizza.
Oh.
Right? If I just ordered a whole pizza from Papa John's and then we cut it up, it would still be pizzagetti, but would it be as good?
I mean, only if they include that garlic butter.
Philistine. Okay. Now that you've mastered how pizzagetti and decimals form greater wholes, let's learn that shortcut. Say you have a problem that asks you to compare 0.5 to 0.312.
Yeah, I can very easily imagine having that problem. I just did.
Okay, here's the shortcut. First, we have to line our decimals up by stacking them, so let's do that now and fill in the digits. Now what do you think?
Oh, we just changed directions. That's not a shortcut.
Well, I thought you might be able to guess what we do next because it involves another one of your heroes. After we line up the decimal, we have to fill in any missing places, so both of our decimals have an equal number of places. That way, when we're comparing the same thing. What number can I use as a placeholder?
Oh, now this I'm sure of. 0, my hero.
Correct. Let's do that now. Remember, we said that 5/10 is equal to 500 thousandths, so we can trade out the 5 and replace it with 500. And we haven't changed the value, only how the number looks. Now that we made the change, is it easier to tell which one is bigger?
Oh, yeah, the top one, because 500 is more pieces than 312. And it's closer to 1 on the number line. I remember that.
Exactly. So if you want to take the shortcut, line up your decimals, make them look the same by adding those zeros, then compare them like you would a whole number by seeing which one is literally bigger than the other.
I see the path, and it is shorter. Mr. Manel?
Yes.
Mr. Manel?
Yes. What?
Mr. Manel?
What?
What if you're comparing numbers that have decimals in the middle? Like a mix of whole numbers and decimals that have numbers in the tens place and the ones place and decimal places. And what do we do?
I'm glad you asked. We can still take that shortcut because it lets
Oh.
us compare similar things.
Oh.
Okay? You start off by lining up your decimals like this. Okay?
Oh.
I've got my decimals lined up.
Decimals
Okay?
are in a line. Yep.
Right. So now,
And those indicate
I can
the
just-
line.
thank you. I can just fill in my 0 in the extra place, and now I can clearly see
Oh.
which one is bigger. Okay?
Yeah, well, I mean, that decimal seems bigger, but then when I look at the whole number, then that number's bigger. So, the 10 and 450 thousandths is bigger.
Yes, because 10 is way bigger than 3. Like, this doesn't even have anything in the tens place,
Yeah,
and this is a
yeah.
1. So,
But if I was just looking at the decimals, I'd get confused.
right, well, that's why you got to look at the whole number places as well. Okay,
Okay.
when you're comparing numbers. If they have
Okay.
decimals.
But what if one number doesn't have a decimal point and the other number does? Then what do we do? How do we line that up?
Well, when a number needs a decimal point, where can we pin the decimal?
On the posterior of the number. Posterior is a fancy word for butt, which in the case of a number means after the ones place.
Thank you for that very thorough and correct observation. Okay, let's take a look at a demonstration on the whiteboard.
Okay.
If you're comparing a whole number with a decimal, the same rules still apply. Okay, you still need to line up and stack your decimals like this. Here we have 2.28 or 2 and 28 hundredths and 4, 4 being the whole number. Well, okay, we pin the decimal on the posterior of the 4.
Fancy.
Okay, and then we can line the decimals up. So now we just fill in our extra spaces with,
Oh, my hero.
that's right, the
Aw.
zeros, and we can see pretty clearly which one is bigger.
Oh, so the 4 is greater.
The 4 is greater. I'm thinking
Yeah.
of like money again. I know that seems to work best for you. Okay, which one's more, $4 or $2.28?
I mean, $4 is more, but a Benjamin is more than both.
Your consistency is admirable. You know that?
Yeah, I'm an admiral now. Sweet. When do I get to command my own ship?
Oh, the duck stole your boat. She took it south for the winter.
What? No, I thought we were friends. This means war.
All right, take
Ready
it.
the cannons.
All right, take it easy. All right.
Oh.
Let's sum up what we've learned today.
Oh, a recap.
Yes.
Ah.
Okay, so to recap. Yeah, you ready?
Yeah.
Okay, when you compare decimals, it's different than it is with whole numbers. Okay?
Yeah.
Because you're dealing with smaller parts of a whole. Okay?
Mhm.
We also used a number line and learned that some decimals
Mhm.
have different names and look different,
Yeah.
but they're
Same.
still worth the same
Yeah,
value.
same amount.
Like 5/10 and 500 thousandths.
Yeah, we could trade them.
They're both half of a whole. Okay, yeah, you
Yeah.
can swap them out to make your comparisons better.
Yeah.
Okay, that's like adding the zeros to fill in the place values.
Yeah, that was our shortcut.
Right, that was a shortcut. We line up our decimals, we fill in the zeros and the place values.
Yeah.
So that's your way of making the comparison a little
Yeah.
bit easier once you
And they
fully
look
understand.
the same.
Yeah, once you fully understand what those decimals mean, because
Yeah.
that is the goal here.
Yeah.
Alright.
The whole
So-
pizza,
Yeah, the whole pizza.
start to finish.
Yeah. All right.
Yeah.
So what's next, man? You in the mood for some more math?
Heck no, I'm gonna get that duck. Oh, wait. You promised pizza-getti. Start slicing.
War with a duck and pizza-getti.
Yeah. It's gonna be epic.
It's gonna be a long night.
This concludes our lesson, guys. We got plans. See you next time.
Bye.